The supernova. The final gasps of massive stars are devastating. In this brief presentation, we will explore the history of this celestial phenomenon, its physical properties, as well as its role in our universe. First, let's explore the basic qualities of supernovae that some of us may or may not already be aware of. So, what is a supernova? Simply, a supernova is an event where a massive star explodes. They release electromagnetic radiation and cosmic rays. Gamma ray bursts are sometimes associated with supernovae. We also must understand that a supernova marks the end of a massive star's life, and they also have the ability to outshine its home galaxy. In addition to the massive amounts of energy released, stellar material is expelled out into space at velocities up to 10% the speed of light. Intriguingly, the material that the star sheds during a supernova contains more heavy elements. These heavy elements form as the explosion occurs. Now that there is a foundation for the concept of a supernova, you may be wondering, how did astronomers first discover this astronomical wonder? Supernovae have been observed primarily in the last few hundred years. According to the Encyclopedia Britannica, only 7 are known to be recorded before the early 17th century. Chinese astronomers observed a supernova in 185 AD, referring to it at the time as a guest star, meaning that the light appeared where no star was visible before. RCW86, a region of emissions in the Milky Way, is now believed to be the remnant of that supernova. In 1054 AD, we had what was considered the first widely observed supernova, which is known as SN 1054. The remnants of this supernova are known as the Crab Nebula. Prominent astronomer Johannes Kepler wrote in 1606 an important text regarding supernovae, titled De Stella Nova, which translates to the new star. Novae also exist in astronomy, but are known to be caused by a binary system of stars where a white dwarf accumulates mass from its red giant companion, and a nuclear explosion occurs. Supernovae were differentiated in the early 20th century because of the difference in scale and event. Even today, it is important to regularly study supernovae because they only occur an average of 3 times every century in our galaxy. It is also important to understand how astronomers identify and go about studying supernovae. Astronomers name supernova by the year they are observed, with a prefix SN for supernova. Recently, letters may be added to classify different supernovae that occurred in the same year. For example, a supernova observed in 1947 was named SN 1947A. But in this case, only one occurred in 1947, so this name is actually quite unique. This name was the last time an extra letter was added that was unnecessary. Today, computer-controlled telescopes and charge-coupled devices are used in the search for supernovae. Notable installations include the Katzmann Automatic Imaging Telescope, as well as the Hubble Space Telescope, which study these celestial explosions. Using observations from the Hubble Space Telescope, CU Boulder research associate Kevin France says that energy input from supernovae regulates the physical state and the long-term evolution of galaxies like the Milky Way. This proves how study of supernovae are allowing astronomers to further understand our universe. There are 2 major types of supernovae, Type 1 and Type 2. These types are based on the spectral curves of the supernovae. Type 1 shows no hydrogen lines, while Type 2 does. There are other, more specific classifications within these 2 types of supernovae. Here's a chart comparing the various classifications of supernovae by their physical properties, including absolute magnitude, energy, days to peak luminosity, and days from peak to 10% luminosity. Notice the unique unit used for energy, FOE. This unit is equal to 10 to the 44th power joules, a massive amount of energy. The unit was created for the purpose of studying these massive amounts of energy from supernovae. In addition, here's a reference for the luminosity over a period of days based on massive star and white dwarf supernovae. With that, I'd like to end this presentation hoping I didn't put you to sleep.
Godspeed, astronomers.